Hi everyone. So nitric acid gets into our environment from humans, basically from two sources. One is from fossil fuel burning, and we already talked about that in our combustion chapters or module. And the second way is actually from agriculture. And in this module, in this video, I'm going to focus on how nitric acid actually gets into our environment from agriculture. Alright, so first of all, you should have an understanding of the nitrogen cycle. It's a natural cycle in our environment. And basically, nitrogen is about 78% of our atmosphere. And we need it for building proteins, amino acids in our body, and those are the building blocks basically for your skin, your hair, your organs, your DNA. So it's essential. And unfortunately, we can't just absorb it from the atmosphere. And what has to happen is it has to start with the plants. And the plants can't absorb it from the atmosphere either, and what they need is actually bacteria in the earth, which we call nitrogen fixing bacteria, that can actually get the nitrogen from the atmosphere and give it to the plants. Okay, and it's more complicated than that, but that's a simple way of talking about it. All right, and so these plants are able to absorb the nitrogen through the bacteria. And then the nitrogen gets back into the environment or the atmosphere when the plants die, or the animals that ate the plants die. The animals or plants decompose, and that nitrogen actually just gets back into the atmosphere. Now, if you look at this graph here, the red line indicates world population. Notice that the world population has gone up dramatically in a very short amount of time. And what we have found is that the bacteria that were fixing the nitrogen do not provide enough nitrogen to supply the world with food. And so there was a really great invention in the early 1900s, and it's called the Haber-Bosch process. But basically it's nitrogen from the air and hydrogen from the air gives you ammonia. Right? This was like one of the most important discoveries of the last century. And what this actually allowed for us to do is create fertilizers, is the big one. Okay, it's used for other things, but the big one is fertilizers. And with these synthetic fertilizers, we were able to grow more food faster and feed the masses of population in the world. And for example, the bacteria, the scientists estimate that the bacteria we have currently on Earth that fix nitrogen could only produce food enough for 4 million people. Currently, our population is 7 million. And by 2100, it's expected that our population will be about 9 million or 9 billion. So it's going to keep increasing. And so there is a need for some kind of fertilizer that can supply nutrients to the plants and essentially to us. But if you look at the graph here, what happened after we had this increase in population and we started using the Haber-Bosch process, okay, we had a total reactive nitrogen also started to increase. Okay, this is important. Total nitrogen, reactive nitrogen. And the issue with this nitrogen floating around is that a lot of it is not absorbed by the plants. It's about 50% is estimated not to be absorbed by the plants. And so the rest of it just gets washed down through runoff in the soil, into the groundwater, into the streams, lakes, rivers, oceans. And we saw that in the chapter about water pollution. And the the part that is absorbed in the plants it gets eaten by humans or animals and gets excreted later, and actually a lot of that gets back into the environment through the sewage. And what we're finding is that we're not only getting water pollution, but we're also getting air pollution from the nitrogen. And what we know about nitrogen is it's actually one of the precursors to nitric acid. And if you look at this, these two charts here, the one on the top is your SO2, right, which is from burning mainly coal, which gives you sulfuric and sulfurous acid. And if you notice that the emissions of SO2 has decreased pretty much since the 1970s. You saw it going up on an upward direction. And in the 1970s, when we had the Clean Air Act, all of a sudden the factories started having to get emission regulations. They had to get scrubbers to remove a lot of the pollutants that were getting put into the air, and that really decreased the amount of SO2 that was going out into the atmosphere. Unfortunately, we're not seeing the same trend with NOx, and part of it is just its source is from cars. A lot of it's from burning fossil fuel in cars itself, and it's kind of harder to regulate. And part of it also might be from the agriculture as well. All right, well, the takeaway message from this lecture is that the acid rain actually has reduced partially due to the Clean Air Act and the lowering of SO2. But we still see nitric acid being a player in this country for acid rain, and that partially is due to agriculture, which is interesting because not only is agriculture pollution is a pollutant to our water, but also our air. And with an increase in population in the years to come, we're going to need more fertilizers. And what does that mean for our health and our environment? Some food for thought. All right, take care. Bye-bye.